right, homework out. Books open at page 59. There are a couple parts to your homework, but we're going to start by looking at page 59, numbers 1 through 21. Some review homework. So nothing to do with the measures we began looking at yesterday. Page 59, numbers 1 through 21. And have that out in your books open, as I said, to page 59. Let's see this first. There's the 1 through 21. And there was also over on page 62, you were finishing up the 10 through 21. Excellent. Right, there's your 1 through 21. All right, and over one more page, you just had to finish up that section, and you're good to go there. Excellent. All right, and you're good to go, and we already checked the other yesterday. All right, let's go and take a look at this homework together. Number 1, identify the place and the value of the underlined digit. What is the place of the 4 there, Scott? Thousands place. So the value would be 4,000. Good. Number 2, the English alphabet has 5 vowels and 21 consonants. What's the ratio of consonants to total letters, Joshua?
21 to 26.
Good, 21 to 26. Number 3, Alana, what order should we put those in to go from least to greatest?
0.2, 0.203,
203.
0.203, 0.225, 0.23, and 2.0.
Excellent job. 0.2, 0.203, 0.225, 0.23, 2.03. How would we prime factor 225 using exponents, Scott?
5 squared times 3 squared.
Good. 3 squared times 5 squared. Number 5, rounding to the hundredths place. Joshua?
18.72.
Good. The 4 is not big enough to bump it up to a 3, so the 4 and 9 just fall away. 44% as a reduced fraction, Lana.
11/25.
Good. You make it 44 over 100 and then reduce them both by 4 to get 11/25. How about 2.3% as a decimal, Scott? 0.023, move the decimal 2 places. How about 3/8% as a decimal, Joshua?
0.00375.
Good. Initially 0.375%, then move the decimal twice, 0.00375. 0.055 as a percent, Lana?
5.5%.
Good. Or 5.5%. 5.5%. Good. Number 10, 32% of 75, Scott?
24.
Because we remember of means. And we'll write the 32% as 0.32 and then just multiply. Number 11, 44 is what percent of 80, Joshua?
55%.
Good. We need to say that 44 equals x times 80, divide both sides by 80, so we end up dividing 44 divided by 80 to get 0.55, which is 55%. Number 12, 63 is 90% of what number, Lana?
70.
70, we would say 63 equals 0.9 times x, divide the 0.9. So 63 divided by 0.9, of course we don't divide a decimal, so make it 630 divided by 9, which gives us 70. Very good. Some fraction review here. What'd you get when you subtracted those mixed numbers, Scott?
1 and 11 twelfths.
Good, 1 and 11 twelfths when you reduce. Initially 1 and 33 36ths. Good job reducing. Number 14, when you divided, or really multiplied by the reciprocal, Joshua?
7 and 2 sevenths.
Good, 7 and 2 sevenths. What's 47% of 94, Lana?
0.4418.
Well, only 2 decimal places, right? You have 0.47, that's 2 decimal places. 94 doesn't have any, so should have just had 2 in there, 44.18 for our answer there. Remember, you don't need to move the decimal 2 extra, right? Because you're not finding a percent. You're just saying, what is 47% of 94? So we multiply 2 decimals. That's what I'm saying. I think you moved it 2 more places out of habit. Think, okay, let's change it to a decimal, but it's not. Number 16, what's the missing value of x in that proportion, Scott?
45.
45. Good, equal ratio method times 3. Could have also cross multiplied, but it's a lot easier equal ratio method. Number 17, that complex fraction, Joshua.
1/17.
1/17, very good. Number 18, Lana, 15 is what percent of 40?
37.5%.
Good, 37.5% or 37.5%, excellent. And then a couple of word problems. On our last visit to the veterinarian, Joni's cat weighed 16 pounds. Today's visit, Joni's cat weighed 14 pounds. So obviously her weight went down. We're not sure what happened. But anyway, what is the percent of change for the cat's weight between visits, and was it increase or decrease? Class, to find percent of change?
Change
over
over.
original.
Change over original. What's the change here, class?
2.
And the original was?
16.
As a fraction, reduce it to?
20.
With as a decimal is? 0.125. So as a percent?
12.5%.
12.5 or 12.5%. And would it be increase or decrease? Decrease. Her weight dropped, or I don't know, it doesn't say the cat's a her. Joni's a her. Anyway, the cat's weight dropped. So decrease. Number 20. A store advertised a going out of business sale for 75% off all items with a yellow tag. There was a store in Pensacola where I was growing up. Every weekend, they would pay people to stand out on the busiest intersection with signs advertising their going out of business sale. For about 2 years, they had a going out of business sale. I was like, are they just going to go out of business already? Then they got creative. Flood sale, fire sale. They just make up reasons. They just basically wanted to have sales to try to get you to go in and buy stuff. That was probably overpriced to begin with. I don't know. It struck me as weird as a little kid. I say little kid. Younger than you guys, though, right? Younger than you guys. And every weekend, going out of business sale, going out of business sale, going out of business sale. I wonder how long they're going out of business. 2 years. Anyway, that's totally random. Has nothing to do with the problem. If a yellow tag item was $24 regularly, what was the discount and what was the sale price of the item? How much was the discount, first of all, if it's 75% off, Lana?
$18.
$18 that you save, so you only end up spending, Lana? $6. Very good. So your discount is $18 and your sale price is only $6. That's before tax. All right, number 21. A football team won 4 regular season games in 2010. In 2012, they won 225% more games. How many games did they win in 2012? What would I need to do here if they won 225% more games? Scott? 2 ways I could do it.
You could make it 325%.
Good. If they won 4 games in 2010, if in 2012 they won 100% of the games that they won before, they would have again won 4. But they didn't. They won, and not 225% of the games. That would just be multiplied by 225%. They won 225% more games. So that means we could add a 225% to get 325%. Multiply by 3.25, that would give us how many wins? 13 wins. Or, the other way is, well, 225% would be 9. But that's 9 more, and so we could add the 9 games and still get 13. Either way is fine. How many had 13 wins in 2012? All right, excellent questions on that. So they went from a 4-12 season to a 13-3 season, assuming we're talking about an NFL team. Questions on the homework? Any questions on percents? Percent more, sale, discount, anything like that? You have a feeling of impending doom, Lana? Your face is like, oh no, I think I know what's coming. Yeah, we are going to have a quiz. So clear your desk except for a clean sheet of paper and a pencil.
Wait.
Clean sheet of paper and a pencil.
What's the more than the more percent?
Percent more just means you have to add it on. So like the last problem, you added the 9 games onto the 4 games to get 13, or you add the 225% to the 100%, either way. But you have to do some adding when it's percent more than. All right, sheet of paper, pencil, everything else away. To give you another opportunity to show me how smart you are. That's why. Wouldn't it be a shame if you were like a genius and I never had a chance to find out just how smart you were because I never gave you quizzes? Would that be sad?
No.
Oh. No. You'd be like, what's the point of learning this? He never gives me a quiz over it. See now? You learn it and get a chance to show me. First and last name at the top of your paper, along with today's date, which is 9/11/20, or you could write Patriot Day 2020. 9/11/20, or Patriot Day 2020, today's date. Of course, your first and last name will go in the name spot first. Let's take a look at the quiz together. Very straightforward on numbers 1 through 7. Just do what it says, answer the questions. And then numbers 8, 9, and 10, got some word problems here. Be sure to show your work on each of those word problems. You may begin. quiz copy, or the blank sheet of paper as a cover sheet. You could work the cover. If possible, try to do work on it off to the side of the quiz if you can. If you need that extra sheet of paper to work on, you may. About 2 or 3 more minutes to be finishing up. we'll go ahead and take a look at this quiz in our next lesson. For now, I want to do a little bit of review with our memorized measures. So Maddie, I need to take you away from your work for just a minute. If you could keep score for us. I'm going to tell you who to put the point down for, and you will keep score for us. Blurt out the answer for me, okay? So blurt it out, and I will do my best to hear who says what first. So we'll see how we do on these measures.
12.
Lana.
366.
Scott. 366.
5,280.
Ooh, you almost caught up to her by the end. She did finish just a nudge before you, but she got a big head start, and you still almost caught her. 5,280 feet.
8.
That was Joshua, just a nudge ahead of you, Scott.
4.
That was Joshua again.
4.
That was Lana.
1,760.
I think Scott finished before the rest of you guys. I think he got it out before the rest of you.
100.
Lana, 100 years in a century.
2.
2. This is the new one, remember? 2 tablespoons equals a fluid ounce. 16 fluid ounces in a pint. Remember, pints a pound the world around?
2.
2 pints in a quart.
2.
2 cups in a pint.
7.
That was Joshua.
24.
24 Lana.
36.
36 Lana. 36 inches in a yard.
12.
12 inches in a foot. Scott.
1,000.
I think Joshua first. 1,000.
10.
10 years Lana in a millennium.
20.
20 Scott in a score.
365.
365.
52.
52 weeks in a year, approximately, right? That's what the little squiggly equal sign means.
60.
60 minutes in an hour.
60.
60 seconds in a minute.
30.
I think that was Joshua again.
12.
5,000.
Wait, what?
3.
3 feet in
No.
a yard. 3 feet in a yard, Scott.
2,000.
2,000 pounds in a ton.
16.
16 ounces in a pound.
4. Wait, 8.
8.
No.
8 quarts in the peck, remember? So analogous, a peck is kind of like 2 gallons, but of dry measure.
12.
12. All right, so what do we got? This sounds like it'd be really close for a change.
No, that's Scott.
What do we got here?
Scott has 12.
12.
Joshua has 6.
That's it?
And Lana has 11.
What?
I thought you had a lot more than 6. I don't know.
What?
All right, so Scott wins again, but just barely. That was good. That was good. We'll give the others of you a shot at him in our next lesson. We'll go through those again. For now, turn your books to page 62. Page 62, and let's run through our answers on the second part of our homework, which was to finish, if you hadn't already, 10 through 21 at the top of page 62. So we were doing these in class, didn't have a chance to finish them, at least we didn't all have a chance to finish, so had you finish those for homework. What I'm going to do for sake of time is just read through the answers very quickly. If you missed one, mark it wrong, and then we'll go over why you missed it later. So going across the top row, starting with number 10. 3 3/4 or 3.75. I think it actually said to use fractions as remainders. Yeah, so fractions, 3 3/4. Number 11, 6 1/2. Number 12 is 84. Number 13, 8 3/4. Number 14, 3. Number 15, 15,840. Number 16, 13. Number 17, 2 1/2. Number 18, 96. Number 19, 14. Number 20, 56. And number 21, 6. Was anyone able to go, let's see, 12 for 12? You got all of them right. Okay. Joshua, how many did you miss?
2.
Just 2. Which 2?
13 and 15.
13 and 15. What did you have for your answer on 15?
And 16.
And 60, so missed 3 of them. Okay. What did you get for 15?
I got 17 and 3/4, but
For number 15.
yeah.
Yeah, you must have misread something there, right? You on 15? Or are you looking at 13?
I'm at 13 on that.
Okay, I was asking about 15 first of all. What did you get for 15?
15. Well, I changed it, 5,280 at first.
Okay, yeah, so you should have multiplied the 5,280 times the 3. Yeah, don't change the answer because that doesn't help me
Yeah.
help you. What about the number 16? What did you have originally?
94.
Really? On number 16?
Yeah.
Because you wouldn't have multiplied or divided by anything there in that case, right? So remember, we're going from small days to larger weeks. We divide by the 7. Huh. And number 13, you said you had what originally?
17 and 3/4.
17 and 3/4. Again, should have divided by 16, so maybe just a division error there. Now, here's the nice thing, though. This whole larger to smaller, multiply smaller to larger, divide, we've got a way around it. I'm going to teach you today a way that you don't have to ever worry about smaller, larger, larger, smaller, and it's a process that's going to help you a little bit this year, but especially as you get into science classes, help you a lot. But we're getting to that here in just a moment. Let's take a look at the word problems here, number 22 through 25, and Joshua, read our first word problem for us.
Is it the one?
Number 22. 22.
Oh.
Right below the homework. Same
Yeah.
thing.
Joshua walked 480 minutes this week. How many hours did he walk?
All right, at your seats, find it. At your seats, find it. All right, Josh, we going from larger to smaller or smaller to larger?
Larger to smaller.
Good, we're going from excuse me. We're given minutes, right, which are small, and we're asked for hours, which are large. So we're going from smaller minutes to larger hours. We should be doing what here, class? Dividing by 60. Should be dividing by 60. By the way, if you use a fraction bar to show your division, you knock the zeros off really easily. We memorized that. We were little. Should be 8. So that probably should have been done in about 6 seconds maybe. Number 23. Go and read that for us, Lana.
Bag of dog food weighs 30 pounds. How many ounces of dog food is it?
At your seats. Take about 15 seconds for this one. So again, number 22, 8 hours was our answer. Lana, do we multiply or divide?
Multiply.
Because we're going from bigger pounds to smaller ounces, we multiply by what?
16.
16 to get?
480.
480 ounces of dog food. Good. How many had that for 23? All right, by the way, remember when you multiply the 16 by the 30, multiply it not by 30, but by 3. 18, carry the 1, you get 48, tack on a 0. That's how you're done in 15 seconds. Should not take you that long to work these. Number 24 is just kind of a thinking question. Which of those years, they've got several listed there, were leap years? Scott, what are we looking at to determine whether or not it's a leap year?
They're divisible by 4 or 400.
Good, if they're divisible by 4, except the years ending in 00, then those have to be divisible by 400. So Scott, let's go through this one at a time. 1607, yes or no?
No.
No, because 07 doesn't divide by 4. What about 1620?
Yes.
That's a significant year, by the way, class. What happened in 1620?
The Mayflower? No.
Mayflower landed at Plymouth Rock. Yeah, good. 1700, yes or no, Scott?
No.
No, because it's not divisible by 400. Good. What about 1776?
Yes.
Yeah, that one is on our 4 times tables, right? But you're looking at the last 2 digits, remember. That's how you know if something's divisible by 4. 4 goes into 7 one time with 3 left over. 4 goes into 36 9 times. So yes, 1776 course class, what happened then?
Depression.
Declaration of Independence, okay? Not the start of the American Revolution or the War for Independence, but kind of in the midst of it. 1800, yes or no?
No.
No, again, like 1700, not divisible by 4. What about the year 2000?
Yes.
Yes, because 2000 divisible by 400. Questions on those for the rest of you? All right, and then Joshua, back to you. How many days passed from January 1st, 1995 to December 31st, 2004? Joshua, what are we going to have to do to figure that out?
Subtract? Wait, no.
Kind of, yeah, a little bit. We have to figure out how many. It says how many days passed, but let's start by just figuring out how many.
No. Wait, no, years.
How many years have passed, right? How many years passed from January 1st, the start of 1995, to the very end of 2004? How many years was that? How many years, Joshua? Okay, there's a really easy way to do this. 95, 96, 97, 98, 2000, 2001, 2002, 2003, 2004.
Yeah, no.
Okay, so you can just kind of figure it out on your fingers, right? Actually, I think I miscounted on my fingers somehow. 95, 96, 97, 98, 99,000. Did I skip one? 1, 2, 3, 4. So it should be 10 years past, right? From the start of 95. So we have all of 1995, right? Is included in there, correct? From January 1st, the whole year of 95 is counted. All of 96, all of 97, all of 98, all of 99, all of 2000. All of 2001, all of 2002, all of 2003, but it's December 31st of 04. So all of 2004 also. That's why you can't just subtract the year. So 10 years passed. How many days in a year, class? 365. So how many days is that?
3,600.
Right, tack a 0 on the end. But how many leap years were in there between 95 and 04? How many leap years? Well, it depends on which year you're looking at. Was 95 a leap year, class? No. Would 96 have been a leap year? Yeah, so 96 is a leap year. What about 97? Now, what's the next leap year after 96? 2000. Is 2000 a leap year?
Yes.
Yes, it was, because it's divisible by 400. What would have been after 2000? 2004. Well, that's included, right? Because the leap day is before December 31st, 2004, so we add on 3 extra leap days, 3,653 would have been our answer there. That's how many days passed between them. All right, move down to the bottom of the page. I want you to do 1 through 9 in the homework section. 1 through 9 in the homework section. A little bit more conversion. Remember, smaller to larger, divide, larger to smaller, multiply. Again, what's the conversion unit? That special number, as it was called in elementary school. And do we multiply or divide? Take another minute or so to finish up as much as you can. Lana, 21 days, how many weeks?
3.
3 weeks, 144 inches, how many feet, Josh?
12.
12. 300 years, how many scores? Scott? 15. 8 quarts, how many pints, Lana?
16.
16, multiplied by 2. 16 tons, how many pounds, Joshua?
32,000.
32,000. 1.5 hours, how many seconds? Looks like we did. Anyone else get that? Yes, sir.
900.
No.
5,400.
5,400, because it went from hours to seconds.
Oh.
So 1.5 hours would be 90 minutes. But then I need to figure out how many seconds multiplied by 60 again to get the 5,400. So a couple of you missed that. Good job, Lana, getting that. Let's go back to Scott for redemption. 96 quarts. How many pecks? 12 dividing by 8. 10 tablespoons. How many fluid ounces, Lana?
Okay.
How many tablespoons in 1 fluid ounce?
42.
2. So if there's 2 per fluid ounce and there's 10 tablespoons, that's...
20.
It takes
Wait.
2 tablespoons to make a single fluid ounce. So a tablespoon is smaller than a fluid ounce. We're going from smaller tablespoons to larger fluid
5.
ounces. Divide by the 2 to get 5. And then 2 pints. How many fluid ounces, Joshua?
I didn't even get that one.
Well, how many fluid ounces in 1 pint?
16.
So if I have 2 pints, that would be
32.
32 fluid ounces. Good. Questions on those? Questions on those? All right, I want to look across the page at something that I mentioned. It takes the pressure off of you having to remember, wait, do I multiply? Do I divide? What do I do here? It's something called dimensional analysis. And dimensional analysis is going to use something we normally try to stay away from to make our life easier. That's fractions. You're familiar with this already, right? If I were to take a fraction like 3/5, that's equivalent to 9/15 because I multiply by 3's. And it's okay to multiply by 3's because you're really multiplying by 3 over 3, and 3 over 3 class equals 1. If I were to take 7, which is 7 over 1, and I were to multiply this by 5/5, I would have 35/5. But that's still equal to 7, because I really just multiplied it by 1, Joshua, looking up here. When you multiply by something over itself, it's just 1. You haven't changed anything. Well, realize sometimes something over itself can look a little bit funny. That's 1, because it's 8 over something that is equal to 8. This is still 1 because it's 7 over something that's equal to 7. Does that make sense that these are still just fractions that are equal to 1? So if I took 12 inches and I put it over 1 foot, because these are the same thing, this fraction equals 1. Dimensional analysis then uses this kind of thing to help us figure out how to convert units away, because, drop this off to the side of the page, we always multiply. With dimensional analysis, we always multiply, which is nice. We don't have to wonder, what do I do? You just always multiply. There's no remembering, do I multiply, do I divide? Takes the question out of it. It kind of takes care of the work for you. Now, I'll be honest, dimensional analysis for you guys in this class is going to seem like, why don't I just do it the old way? That was easier. Because you've got the smaller, larger, smaller thing down, and you're going to be working with pretty basic units. You're going to, in physical science a little bit later on, in chemistry later on, in physics later on, you're going to get into some units that get pretty gnarly. Is that a good word for it? And dimensional analysis helps you keep up with what's going on. The idea is this. If I were given 6 feet equals how many yards? Instead of even thinking larger to smaller, smaller to larger, I don't think about that. I think about what's the relationship between yards and feet. Class? 3 feet in a yard, right? So I can do this. I can start by writing my 6 feet and I put it over 1. I make it into a fraction. And then I multiply it by another fraction. Now, this other fraction has to equal 1. We know there's 3 feet in a yard. So I could either say 3 feet in 1 yard, or I could multiply by 1 yard over 3 feet. You understand either way, I'm multiplying by a 1, right? But here's the key to dimensional analysis. You're going to try to get the units to cancel. If I were to multiply like this, feet and feet don't cancel because in multiplying fractions, you never cancel side by side, right? Like if you had 6/7 times 3 halves, you can't cancel 6 and 3, can you? But you can cancel 6 and 2, correct? Feet and feet don't cancel. So I'm not going to multiply by this fraction. I'm going to multiply by this one so that feet and feet cancel. Now, clearly, the fraction bar shows me what to do. I get 6 yards divided by 3, which equals, of course, 2 yards. Now again, on the surface, you look at that and say, I already knew it was 2 yards. You know, but because of where this leads, that's why it's important for me to teach this to you. So if I had, 2 miles equals how many feet? Well, again, you're going to start by writing the given value down as a fraction, 2 miles over 1. And I'm going to multiply this by a fraction. Now, we know, class, there are how many feet in a mile? 5,280. Question, should I put 5,280 feet over 1 mile, or should I put 1 mile over 5,280 feet? How do you know which way to set it up? I want the mile to cancel with another mile. Would the mile cancel with a mile up here, or would it cancel with a mile down here? Down there. So this is how I'm going to multiply it. The miles cancel. My denominator now is just 1, so it's basically worthless. And I'm going to multiply 2 times 5,280 feet. Again, you already know to do that, but as units get more complicated, that's where this is going to be of benefit to you. And what'd that be at 10,560, I think? Anyway, so this is how we'll keep up with not wondering, do I multiply, do I divide? You multiply by the fraction in such a way that it forces a canceling to happen. Look at the example problem there. 4 minutes equals blank seconds. Notice what they did. They just put 60 seconds over a minute because they're the exact same thing, right? 60 seconds, 1 minute. If I say, all right, you have 1 minute to work. Or if I say, all right, you have 60 seconds. Yes, he gave us more time. No, it's the same amount, right? 60 seconds, 1 minute, big deal. But by putting the 60 seconds over a minute, notice they were able to cancel the minutes. Looking in your book, they were able to cancel the minutes. And now notice the 4 and the 60 are next to each other. So instead of doing any canceling, you just multiply. 4 times 60, 240. But look at the next example below it. 34 cups equals how many pints? Well, you put 1 pint over 2 cups. That way the cups and cups can cancel. Well, now you can also cancel 34 and 2 to get 17 and 1. Or they just multiplied across to get 34 over 2. And you get 17. In a sense, dividing, but it took the thought out of what do I have to do? Am I going larger to smaller, or am I going larger to smaller to larger? I'll tell you where this is going to perhaps help you, is in those word problems where you can't remember, wait, am I going from larger to smaller, smaller to larger? And I've seen it happen on tests with good students who normally make A's and B's. And like, I don't know. The classic example that I can think of in looking back on years of looking over papers is blank feet is equal to 3 yards. And students are like, oh, I'm going from feet to yards. No, you're not. You're going from yards to what you're trying to find, which is feet, but students don't think that through. You don't have to think it through. Put the given value over 1, and how should I, sorry about that, out of habit, how should I set up my fraction? 3 feet over a yard or a yard over 3 feet? 3 feet over a yard. Why does it have to be 3 feet over a yard, not a yard over 3 feet?
So the units can cancel.
So the yards can cancel. And now I do 3 times 3, which of course class gives us 9 feet. Okay, so that's the idea behind dimensional analysis. Now, this is more helpful when you have to get into multiple conversions. For instance, look at the next example problem. This is similar to kind of the 1.5 hours is how many seconds problem. This is useful when you have multiple steps involved. Look at the example. 8 gallons equals how many cups? Well, we don't have that memorized, do we, gallons to cups? But we're still going to start the same way, class. We're going to put our given value over 1. Good, Lana. 8 gallons over 1. What do we know about gallons?
4 quarts.
4 quarts. Now, 4 quarts over 1 gallon or 1 gallon over 4 quarts?
4 quarts.
Good. 4 quarts over 1 gallon. And the gallons are gone. I now have quarts, but I don't care about quarts. I want cups. So let's multiply again. What do we know about quarts?
2 pints.
2 of that, 2 pints in 1 quart, right? So 2 pints, 1 quart, 1 quart, 2 pints?
2 pints.
2 pints.
2 pints over the 1 quart. The quarts cancel. I now have pints, but that's not what I want. I want cups. So now I multiply by another fraction. How should I set up my last fraction?
2 cups, 1 pint.
2 quarts and 1 pint.
2 cups
I mean, 2
over
cups.
1 pint. That way the pints and pints cancel. Notice the only unit left is cups. And according to this, I don't have anything to multiply down here because it's all ones. So I just multiply up here. 8 times 4.
12. I mean, not 12.
32.
32 times 2.
64.
64 times 2.
100.
128. And there's our answer. So multiple conversions, this can be especially helpful because you just keep writing down fractions until you get to a stopping point where whatever unit you want is left over. Look at the example there. 160 quarts is how many bushels? 160 quarts is how many bushels? Actually, for sake of time, let's just look at it in the book. Notice they started by saying, well, I know 1 peck is 8 quarts. So they put the peck over the 8 quarts so the quarts cancel. Well, I know a bushel is 4 pecks. So they put a bushel over 4 pecks so the pecks and pecks cancel. Notice if you multiply across the top, it's a 160 times 1 times 1. That's 160. And in the bottom, it's 1 times 8 times 4, which is 32. So they wind up with 160 over 32. And when they divided, they got 5. And the only unit that was left now is the bushels, because all the other units canceled. Do you kind of get the feel for how dimensional analysis works? Again, to be honest, real transparent, if it's my choice and it's just a single conversion, weeks to days, multiply, or days to weeks, I'm going to divide. I already know to do that, right? But on the bigger, longer conversions, this is where it's especially helpful. Look at number 9. Let's do just a couple of these together here. 256 pints equals how many bushels? 256 pints equals how many bushels? All right, well, what do we know? Well, how do we start, class? Put the 256 over 1. 256 pints over 1. What do we know about pints?
2 equals 1 quart.
2 equals a quart. How do we set it up?
1 quart over 2 pints.
And the pints cancel. All right, now I've got quarts. That's not what I want. What do I know about quarts? 8 of them equals a peck. So how do I set it up?
1 peck over 8 quarts.
Put the 1 peck over the 8 quarts, so the quarts cancel. Like Scott dropped out. But now I've got pecks. I don't want pecks. I want bushels. So now what do I do?
4 bushels in a peck.
Oh, there's
so-
4 bushels in a peck?
I mean, no. 8 bushels in a peck.
Ooh.
Wait,
The
what?
bushel's the big one.
No.
Help him, Lana.
4 pecks in a bushel.
4 pecks in a bushel.
Yeah,
What goes where here?
yeah.
4 pecks in a bushel,
Pecks on the bottom.
pecks on the bottom. So 4 pecks in the bottom and the 1 bushel on the top. All right, so when we multiply across the top, 256 times 1 times 1.
256.
And in the bottom, 1 times 2 times 8 times 4. 64. And we just have to divide 256 by 64. How many times is 6 going to 25?
4.
4.
16. 25.
Oh, perfect. So apparently 4 bushels. So he kind of does the whole problem all at once for you, just doing one progression at a time. You're not going to actually practice with this tonight though, okay? So I just kind of introduced it to you. As we come back on Monday after the weekend, we're going to go into it more. But I wanted you to at least see it for a few minutes, kind of get an idea of it, and then Monday we'll hit it a little bit harder. So for homework this evening, I need you to do page 65. Page 65, numbers 1 through 8. Now it says to use dimensional analysis. I am telling you do it the normal way. So page 65, 1 through 8 at the top, do these the normal way. Don't use dimensional analysis on these. Just do them the normal way. On the next page, page 66, do the review 21 to 30. Page 66, do the review 21 through 30. Page 65, numbers 1 through 8 the normal way. Page 66, the review 21 through 30. All right, you are dismissed. Have a wonderful weekend.